Over the last couple months, AI agents have quickly grown to one of the most popular AI apps our customers evaluate. And after fielding thousands of questions on the topic, we're excited to share the insights and best practices we picked up. The first part of the session will be led by Ankur Goyal, CEO of Braintrust, who will cover how to get started with evaluating agent systems, selection and writing of scoring functions, and touch on some real-life examples from Anthropic's guide to building effective agents. Next, Vitor Balocco from Zapier will share how his team has integrated evaluations into their CI/CD pipelines for agentic features like Zapier Agents. We will then end the session with hopefully about 15 minutes of Q&A, but feel free to drop questions in the chat throughout the session as they come up. With that, I'll hand things over to Ankur. Ankur?
Awesome. Thanks, Jack. And good to have everyone here. We're super excited. First and foremost, I want to say thank you to Vitor. Vitor has been a good friend and extremely early Braintrust user, and has given us, immense feedback and support over the past few years. And it's just been a lot of fun, kind of building and seeing Zapier AI come to fruition together with Braintrust. All right, so let's just start by setting some context. Building good agents is really hard. I think there's a variety of reasons for that. The first is that AI engineering, and I think agents in particular, is a new discipline. It's not something that anyone, like if I put this slide up 3 years ago, it would make no sense to anyone. And so I think it's worth kind of recognizing that this is a totally new field. At the same time, I think one of the most important things we've learned and we've seen from companies that are building AI really well, like Zapier, is that good agent and AI engineering is really just like good engineering, as we've learned how to do over the past few decades. And so I think a lot of the learnings that we've had revolve around kind of a few key principles. The first is that evaluations are incredibly important. I actually think that in AI, the entire engineering sort of development loop that's done really well actually revolves around evals. Sometimes when we meet customers, they're, hey, evals, like maybe I should add evals to my application. That's usually where people start. But eventually, what we really like to hear when we talk to folks that are very advanced is, oh, we're thinking about this idea. We're currently putting together some evals so we can figure out how feasible it is or what it will take to actually implement it. And so I think evals are just insanely important. In the context of agents specifically, you're basically adding a bunch of complexity to an engineering system, and every node or component of the system is itself non-deterministic. And so evals are kind of a critical component to making sure that the building blocks that you're kind of putting together for a complex agent are actually able to work and scale in the first place. When you're building evals, and I think this is one of the new and kind of interesting things about AI compared to the previous generation of engineering, you actually kind of want to think about both quantitative and qualitative measures. And so on the quantitative side, I think sometimes you'll have ground truth values. Like let's say you're working in a financial context and you're trying to figure out whether a particular underwriting applicant is fraudulent or not. You might have really good historical data that tells you like, yes, this is fraudulent. No, that's not fraudulent. And you can run tests that tell you whether your new process is accurate or not. And so testing against ground truth is really valuable. And so is actually measuring like system metrics. For example, how much does it cost me to actually run that underwriting process compared to before, and how long does it take? However, I think it's also really, really important to gather qualitative feedback as well. And I think qualitative feedback is kind of like an automated version of what people often do early on, which is called a vibe check. Basically trying to figure out whether the agent that you're creating or the system that you're creating is actually doing a high quality job in a way that would reflect to an end user. So for example, if you're working on a customer support use case, it's not just important that the customer support agent returns the right answer, but it's also important that the user experience is actually really good, and qualitative metrics let you determine that. So the last kind of generic principle I would share is that I think it's really important, as with any form of engineering, to try to be as lazy as you can. And by that I mean, I think probably one of the biggest failure modes for people when they're working on evals is to try to boil the ocean and think about evaluating every single piece of a system perfectly before you just kind of jump in and start the flywheel of running evals well. The process that we usually suggest is actually just starting with end-to-end evals. So if you have, let's say, a customer support agent trying some input support questions and looking at the final output that the support bot generates, going through all the steps that you might introduce along the way, and just getting a measure of how good the final answers are. And the reason that's good is that, one, in kind of a built-out system, you need an end-to-end signal to begin with, so it's an important signal to have. But two, once you do that, if you trace the execution of your agent really well, which obviously tools like Braintrust can help you do, then you can start to find the individual failure points and then write more precise evals based on what's actually going wrong. And I think there's two reasons that that's important. The first is that when you notice that something is actually going wrong, you are able to capture the data right there and then. And so it allows you to build a data set on the fly versus going through kind of an effort ahead of time to build a data set. And the second thing is you end up spending your time on real problems versus imaginary problems. I think we're all probably surprised every day by what LLMs are very good at and what they're bad at. And it's important to prioritize your time on things that are actually important. And then, of course, if you do this, you sort of build a flywheel. And so you can run some evals, figure out what's actually broken, write more precise evals, fix them, and then do the whole thing again until you get really good results. There are basically two mechanisms for encoding evals. The first is to write code, and I think code is super precise. It's easy to reason about, and I think it gives you a very reliable signal. I think one of the things maybe Vitor will talk about is we've seen that many of the sort of leading AI companies use code-based or heuristic scores as kind of their primary North Star metrics, just because they're so reliable. But of course, they tend not to be as great at qualitative measures like the user experience quality or consistency or repetitiveness of a conversation. And so that's where LLM as a judge scores come in. And I think what's actually the most important thing is that you kind of experiment with both and try to figure out a combination that works really well for your use case. So the folks at Anthropic released a really great guide, which I think probably many of the folks here today read. We certainly studied it and found it very insightful. And among other things, I think they did a good job of laying out a few different kind of canonical architectures for building agents of increasing complexity. And so we're going to talk through a few of them and what some of the sort of strategies are for evaluating them along the way. So let's start with something really simple, which is take an input, run an LLM. Maybe it has like one tool call to do retrieval or access some memory, and then it generates an output. And here, I think factuality is a really powerful metric because it kind of gives you that end-to-end score of whether the final output was accurate, independent of what tools you call or retrieval or memory, whether or not it was accurate. I often do kind of like an ablation style thing if I do RAG, where I'll actually test factuality with retrieval, and then I'll remove the retrieval and make sure that the factuality score tanks. If it doesn't tank, then you have to ask yourself whether your retrieval is working in the first place. Are you working on a problem that maybe doesn't need retrieval, like you're asking questions about Wikipedia? It's kind of an interesting way of sanity checking the tool calls in the first place. And then there's a few different ways of actually checking the quality of the process in between, which is the retrieval. The first thing is whether or not it actually included any context. And that's something you can just check with code. And the second thing is whether or really how relevant that context was to the question that was originally asked. And I think LLMs are really good at doing that. One of the sort of clever things about testing something like relevance is that it's actually a much easier problem for an LLM to look at a question and some context and say, like, yes, this context is really relevant to the question, or no, it's not, compared to asking an LLM to generate an answer with respect to the context. In the latter case, there's a chance that the LLM might hallucinate. In the former, you've sort of defined the prompt to the LLM in a way that makes it actually very difficult for it to hallucinate. And so I think that's another thing that when you sort of play with these eval methods, you'll observe and build some intuition on. But that's kind of one of the most powerful insights around the effectiveness of LLM as a judge. It's often a much easier task for an LLM to judge things than it is to actually produce the answer. Not unlike us as humans. As you get more complicated, you might still want to keep some of those metrics in place, but you can start to look at things that actually measure the process itself. So for example, in this case, if you're running multiple steps of a chain, you can actually test the correctness of each step. You could use factuality, or you could use something simpler like an exact match scorer. And by the way, all of these scorers are either already built into Braintrust and our auto evals library, or part of code that we distributed with a companion guide to the Anthropic article. So if you're sort of thinking about where can I get this code or whatever, rest assured, it's all available via Braintrust. So yeah, one thing you might do is test, the individual steps of the process, but then you can also actually look at the overall process as a whole and start to ask some meta questions like, did the flow from LLM1 to LLM2, was it actually coherent? I think one of the benefits of doing this is that not only do you actually test the quality of the process, but you might test how important the process is. So if you find that the answers are good, but the coherence from step to step was low, you might ask, do I actually need multiple steps to accomplish this task, or is one LLM call doing a majority of the work, and maybe I can simplify the architecture. As you get more complex, there's even more that you can do. So the first thing is that it starts to become harder to evaluate individual steps. And one of the things that we see is that you might start to ask like, okay, step 2 doesn't have the final answer, or step 3 doesn't have the final answer. It starts to become really hard to use metrics like exact match. I think there's a few different things you can do, but one of the powerful insights is that you can actually use basic accuracy scores. So maybe not exact match, but something like partial accuracy. And instead of getting a binary signal, maybe the partial accuracy of step 3 is 0.6 or something. And really what you might be looking for is if you change something about step 3, or you change something about the entire process, what happens to the relative value of that accuracy? If it goes really low, then that in and of itself is a signal. And if it increases, maybe that is a useful signal as well. So the absolute number, 0.6 or 0.4 or whatever, actually becomes less important than sort of the relative change as you actually change the architecture. And then, of course, there's kind of a more complex set of flow or agent-specific metrics, like actually looking at whether each of the subtasks covers the problem it was trying to solve as you build a more complex system. In some cases, you might build something that's totally autonomous. And I think in particular, this comes into play when you have LLMs sort of asynchronously interacting with humans and the environment. So one thing that you might want to do is actually make sure that this thing converges after some period of time. I think we've all probably played with agentic tools that go off in some crazy loop and never really converge or result in an answer. And actually making sure or checking the number of steps that's required for an agent to produce the final outcome ends up being a pretty good metric. There's some tricky things like how do you normalize it so that you can compare these things over time. That's a whole nother topic, but something that you can dig into as you're actually working on scoring. Another thing that you might actually check is stuff like, does the LLM operate within the bounds of compliance that I've defined for my organization? So this comes up when you're doing stuff like letting an LLM access internal records or communicate with staff internally or users externally to get a particular task done. You might define some compliance boundaries like, hey, the LLM is allowed to check our database n times per minute, or the LLM is allowed to access these fields of the database, but not those fields. It's kind of useful to encode those separately from the task itself, and sometimes even separately from how they're enforced. First, it can be a good way to actually get on the same page about what the spec is for compliance. But two, it's a very nice way of actually verifying that if something changes in how you've actually engineered the LLM or how maybe you've defined a role-based access control policy on a database, that you still stay compliant. So once you actually get kind of like a basic eval loop working, there's a lot of stuff you can do. I think one of the most important things is to build a flywheel of data that you can add to your eval system so that you can do better evals going forward. And what we've seen is that one of the best, if not the best ways to do it is online evaluation. When you do online evaluation, you essentially take the metrics that you've defined to do your offline evals and figure out how to run them in production on your logs. And it's not that crazy, things that score really low on your logs it's kind of a useful signal for what might be worth looking at in your offline evals. Another kind of flavor of online evaluation is actually getting end user feedback. It has some trade-offs, of course. End user feedback is a noisier signal than online evaluation, but you'll also catch things that your online evals don't necessarily find. Again, something Vitor might talk about, but I think the best teams are really good at both of these. And then finally, I think to actually effectively do this at scale, you need to figure out a practical workflow for doing human review. And by that, I mean, I think blindly taking information from your logs or information or feedback from your end users and pulling them into your evals is a recipe for disaster, because I think evals predicate on having really good validation data that you trust. And so human review is kind of like the blood transfusion process of wild information from your logs into kind of the clean, nice data set that you use for evals. And figuring out a good workflow, that means really easy and fast UI UX, making sure that you prioritize people's time so they're looking at the data that's relevant, coming up with the right metrics and rubrics for people to look at. That's also a very important part of the process. So with that, I'm super excited to pass the ball to Vitor, who will talk about how they do this stuff at scale at Zapier.
Thanks, Ankur. I'm happy to be here. Happy to help with any brain trust related. They saved our lives many times building Zapier agents, or we couldn't figure out something, and then it was right there in the logs afterwards, fixing many bugs that would block us, and just chatting and brainstorming ideas. So more than happy to be here. So hey everyone, I'm Vitor. I'm a staff applied AI engineer here at Zapier, and I'm building Zapier agents. Cool. So so I'm building Zapier agents. We actually just launched again. It used to be called Zapier Central before, so you might have heard of us. And Zapier Agents is basically both a chat with your data and AI automation platform all in one. So you can use it as a GPT style, one-off chats whenever you want type of product, and we connect to live data from third-party apps. So we not only we connect them at the beginning, but we also keep them in sync for you. So that means whether if you add like Notion as a live data, we're going to keep that in sync. So when you can ask questions to your chatbot, it will see all the updates that you made recently. And then we also let you interact with all of the 7,000 plus apps that the Zapier platform supports. And that means that you can build recurring workflows. But instead of having to use a workflow builder like Zaps, we have a different twist on that where you can use natural language. So you just describe in natural language what you want your automation to do. Let me see if I can play that video again. And then you give the agent access to some of the actions from those apps, and then you just turn it on and you let it loose with all the plus and minus of what that entails. So we can talk a little bit about that. So an example of it could be, every time a sales meeting is about to start, I will extract the attendees from the calendar event for the sales call, and then I'm gonna have my agent do a Google search for each one of those attendees, summarize everything you find related to the sales call, and then add all of that to Google Sheets so I can keep track of everyone I've talked with, and also send me a final summary so I can prep for the call. And this can run in the background, and I'll receive those summaries before every call, but I can also go to my chatbot and ask it questions like, hey, what are the people I've met? Or have I met with this company before? And it will figure out how to query that Google Sheet on demand for you as well. And architecture-wise, Agent is a bit of a combination of the fully autonomous agent pattern that Ankur was showing before. But we also do a bunch of prompt chaining for pre and post-processing some of the results, doing things like classifying the intent from the user at the beginning. And some of the tools that the agent has access to, they themselves are prompt chains or other specialized agents, actually. So today I wanted to share some of the learnings and the best practices we've uncovered from building agents at Zapier. It's been more than a year now. So I want to talk a little bit about how do you build a good agent. And let's first talk about how to not build a good agent, right? I think you definitely don't want to just prototype a flashy demo that works for the happiest of happy paths and then extrapolate that users are going to follow that same happy path. And I think a very common anti-pattern I see is that you build a prototype with a very strong foundational model, and then the demo gets kind of shared internally, and your stakeholders get excited, and they get so excited that it backfires, and now you're being pressured suddenly to ship the demo to your users. And I think to me the way to build a good agent is to not treat your feedback collection and evaluation system as an afterthought set. As Ankur also mentioned, I think evals are important, right? Like it doesn't matter so much that you build the perfect eval system at the beginning, but it's really important that you spend some time thinking about how you're going to wire up that flywheel, so you can spend some time every day really like looking at a lot of the data that is going through your agent. And really like prepare yourself for that long run, right? LLMs are non-deterministic by nature, so there's going to be for sure a long tail of behaviors that you either want to try to reject, or you want to try to fix, or you want to prioritize or not, depending on how you want to react to user feedback and how people are using your product. So in other words, I think the adventure only really starts when you get here. This is where the fun really begins if you're an AI engineer building agents. And as I said, I'm not saying that you should build or chase a fully automated eval system right off the bat, but you still want to optimize for getting an MVP in front of users as fast as possible. But make sure you have at least the bare minimum system in place so you can start collecting feedback and then leverage that feedback to learn fast and iterate. This is for me the most important part about building AI products. So perhaps that means you have a static list of evals that you can check. Maybe it's even like a Google sheet. They're curated by hand, and you test them every time you're going to ship something, and then you ship that to some users, and then you start collecting feedback, and you start building Braintrust logs for all of the live runs, and now you have this mass of runs that you can comb through and look for interesting insights or runs and build more evals and improve your system. And then from then on, you pretty much just rinse and repeat, right? You're improving your system and adding more evals, and you're improving your flywheel at the same time to get more signal. So now you're at the blue part of the diagram, and this is where you want to work on making sure you're building like a high quality feedback loop with your users. You want to make sure that you have the tools in place to understand the data, that you're capturing the use cases that you find interesting, both the negative and the positive ones, so they don't regress, for example. And you also want to make sure that you can reproduce them in an eval, right? So it does feel like a little bit of work up front, but I promise you that this pays off. Like evals are, I promise you, the most important part of any AI product that you can invest in. Okay, so let's recap. To build a good agent, you have to collect feedback. You need to have the mechanisms in place to collect explicit and implicit feedback from your system. You need to look at and understand your data. So you want to understand where your agent is failing most often, and you want to have ways to cross-reference that with usage data from your product, and that's going to help you guide also which new product features to build, which problems to prioritize, which ones you don't want to prioritize yet. So if you have some use case that the agent is failing 100% of the times, but you only have a handful of users trying that, you might not want to prioritize that compared to something that your agent fails 20% of the time, but thousands of people are trying that, right? You shouldn't really be looking at live runs every day to build your intuition about where to pay closer attention. I cannot emphasize it enough. I think like that probably, besides the whole evals part, the coolest part about Braintrust platform for me is that I can just push all of the logs, all of the traces, and I spend I'm not exaggerating at least 3 hours a day literally just looking at data, looking at feedback reports, and going to the traces and understanding. And that has helped me build such a great intuition, not only about what happens, what works for my product, but also in general for all the different types of models that we've been trying, what works for what, right? So after you understand the data, then you also need to run evals and iterate, right? So that's where the fun part begins. You're able to identify things, runs that are important for whatever reason, or did some interesting behavior that you want to capture. You can capture that, and you can now run it again whenever you need later, because you want to improve either your prompt or the tool description, the set of tools, and you can kind of like tweak all those knobs and have the evals as your safety net, right? To make sure not only you're improving on the specific run that you're focused on, but that you can kind of zoom out and make sure nothing regresses and anything like that. So let's talk about the first step a little bit, collecting feedback. It's important that you are constantly actively trying to find ways to ask and entice your users to give you explicit feedback on your product. And I think that the thumbs down, thumbs up, and thumbs down buttons on every agent message, every product does it now. It's a good baseline. That's probably where you should look into starting. But also try to find those critical moments in your user's journey where they'll be most likely to provide feedback, right? So where's the point in your app, like if they are either very satisfied or very angry at what happened? If you have a call to action, they're like asking them for their feedback. I promise you that they will want to give that feedback more. And I think one of the surprises for us was that once we worked in a few of those call to actions into our product, we started getting a lot of more positives. We practically 5x the number of positive feedback that we were getting, which is also important when you're building an agent, right? Because you want to make sure that as you're upgrading your models or changing your prompt, you're not fixing problems, but you're also not making sure things that were already working don't get worse. So one example of this from our product is when you're building one of those workflow automations that I was talking about. You can test it before you turn it on, and if the automation finished, we asked the user at that point if it did what they expected it to do. There's a very high chance that the user is going to press one of those buttons, and then we show a little pop-up on the screen asking them for a bit more information on why it did or did not do what they expected, and that's been like super high value for us. So here you can see a little bit about how the feedback collection improved, and this was just from showing that CTA. So you can see like practically like 4x the number of feedback that we were getting. Of course, you also want to try to mine user interaction for implicit feedback. I think usually people think that this is a lot of work, but there's actually a lot of low-hanging fruit possibilities here. And one of those possibilities for us is after that test that I was mentioning, if the user presses the enable behavior button, it's probably a very good signal that they are happy with what the agent did. So we can treat that as an implicit positive signal, right? So there's a bunch of other examples that are easy to try to reproduce in your app. One of them is if the user is showing any signs of anger or frustration. Some of those are actually very easy to detect, and clearly that's an implicit like negative signal. If a tool call return an error, that's also a good implicit feedback that you should go investigate why. That probably means either the parameters passed in were wrong or something happened during the runtime that you have to fix. So remember that like there's a lot of like piping, right, when you're doing an agent. So maybe it's not the LLM part of it that's failing, but something else in your system you have to improve. Another example of good implicit feedback is if you're able to, kind of look at the chat history at the end and consider it holistically. If the user sent the same message or semantically similar message many times, one after the other, there's a very high chance that they were not satisfied with the first response and they were trying to like slightly vary it to see if the agent would do better. And that's a good implicit negative feedback of your product as well. Of course, there's like some hallucination cases that once you start looking at your data and like noticing some patterns, they become almost pathological for your app. So for us, one example of this is the agent would kind of hallucinate an email, even though there was no email coming from a previous step, and he would always use like these kind of square brackets with a fake email inside. So you can like literally just like search for do a regex search for like square brackets with stuff inside, and that's some signal that you should go look and check if that was a hallucination case. All right, so step two after that is you need to actually understand the data, and I think this part is also very important, and this is also something that Braintrust has helped with us a lot. You can add metadata to any of the live runs, and you can do this, for the live runs while they're happening as well, which is really handy. And this really helps you understand, where you are failing most often, and kind of get a sense of where you should focus your attention first. So, I think some very classic examples of what you can do here is you can post-process calculate the number of words, and then a number of words, sorry, number of tools. And then you can have a list of all the tool names of the tools that were used, and that allows you to later filter by one of those when you want to just kind of zoom in, like, oh, this tool, I've seen a few of these tools like doing bad lately. Let me just filter on logs for just all runs that had a tool call, one of these tool calls, and let's see what else is going on here. This is a pattern. So you can kind of like start to, test some of these hypotheses, right? Does the higher number of tools in the toolbox of the agent correlate with the higher chance of negative feedback? A spoiler alert, yes, it probably does. That's an easy one, but you can have some fun slicing and dicing your data. And as Ankur said, like human labeling really is like a superpower, at least for as long as you can do it. You really shouldn't be afraid to do human labeling at this point. When Zapier launched Zapier Agents in initial public preview, which was like kind of a limited preview, this was one of the main ways we were able to get that visibility into what quote unquote categories of errors were happening more often. And then that allowed us to focus and prioritize what we're going to focus on, what we're going to work on to improve before the public launch, which happened last week. And thanks to this, we got like a huge bump in our positive to negative feedback ratio, which is one of the metrics that we use to kind of get a sense if we're heading in the right direction. So every feedback submission that we get essentially lands on a triage queue, and then it gets reviewed by someone in our team. And then we categorize it into this predetermined list of categories. You can think of it, as categories of failure modes for the agent. So maybe the agent picked the right tool, but it calculated the tool call parameters wrong. That would be one category. But if it picked the wrong tool entirely, that's a separate category. And now you're able to kind of zoom out and understand, okay, which one of these is the agent failing more right now? Let me focus on that one first and see if we can improve it. And then once you found those interesting runs that you want to improve, and then you need to actually start capturing them into a data set, right? And a tip I have for building useful data sets is, keep in mind, like you can start by just creating these traces of the entire runs in Braintrust, but you don't actually have to, data sets don't actually have to be an entire trace, right? You can have data sets that are built from specific discrete spans in your trace. So try to find those discrete steps in your run where things first went wrong, and then you should consider making that into a data set, right? Because now you have that flywheel starting to spin, and you started collecting like these full logs. You're able to start digging in and capturing a bit more of the information that's going to help you later to come up with some evals that use code scorers, which is a more higher signal for this type of stuff. So, that might mean that if in the first step of your agent loop, the agent decided to call the correct tool, like I was saying, but the wrong parameters, you probably don't need to add the entire trace with all of the other tool calls that followed to a data set, but you could focus on reproducing that first tool and add that span to a data set and then see if you can fix that. And also, of course, remember that the problem might not be in an LLM call. It might be somewhere else. It might be in the tool execution itself, or it can be in a retrieval step if you're doing a RAG pipeline. And I think it's important to remember that in Braintrust, not all the spans need to be LLM calls, right? You can add spans that are just tasks. So try to add, spans for each discrete task that happens in your agent pipeline. And a very cool trick that we've been doing is even if there is one step which is a chat completion, we'd like to wrap that span into another task span. And the inputs and outputs of that span mimic exactly the interface for the function I have to invoke in my eval later. And that makes it easier for us to just kind of like pipe in the data set and run that function with those exact inputs and outputs as expected values to get going faster. And here in the screenshot, you can see an example of one of our traces, which has a lot of different spans that are not LLM calls. For instance, here, there's this span called the planner. There's this, a step where we make an LLM call, but we know we output like a JSON object with the plan of what the agent has to do next. So we have a set of we have a data set which is only about the planner step. Did the planner step do the right thing? Considering everything that was happening before, did it output the JSON that we expected with the correct steps that we expected? And of everything else I spoke about today, I think this is probably my biggest tip for you to transition from, that initial flywheel that captures all of the logs. Like Ankur was talking about, you want to be lazy and build that first and make sure you have that system in place and you're starting to collect that data. But also start looking for opportunities to eval discrete steps once you get there and you see users coming into your product. You want to, I guess I'm starting to kind of see it more or less as the distinction between like writing end-to-end tests and unit tests. End-to-end tests are like really bang for your buck, right? They also almost act like a smoke test for your product, but they are also harder to score. A lot of times you have to rely on all of those subjective scores, and they're also harder to maintain. But the unit tests or unit evals rather, they're easier to maintain and they're often easier to score because you can rely more on scores that are like code base and that do things like string comparison or like Levenstein distance or whatever to give you some nice signal. And some examples of that are if your app does RAG, then you could score the LLM response after you show it the retrieved chunks. But that's usually harder to score. Instead, you should also try to score the chunks that were retrieved, right? You can do like precision or recall score on those, and that could be a data set and an eval script by itself, even if you want. Another example is instead of scoring the entire tool call that the chat completion call return, you could score the tool name that it picked, and separately you can score the parameters. So now you have like two separate scores. The name is very high signal because you just do like a strict string match. And if something goes off there, then the score goes to 0 and you immediately know that something went wrong. And the parameters, I think it depends on your use case, but you also have like a lot of lever there to pull and make it higher signal. So Ankur talked a little bit about this, so I'm not going to spend too much time. But I think for subjective scores, like I feel like a lot of engineers getting into the AI world, like they tend to obsess with getting scores to 100%. So another tip there that I have is the way I see it is like, try to design these scores such that a low score means it needs someone to go look at it to see what's wrong, more than like trying to always get to 100%. Like, except that a lot of scorers will never actually get to 100% sometimes. But it's good. It's more for like helping you see a trend, right? So if the score is going up, that means that things are going well. Or if the score is dropping, then go look at what's going wrong. And online evals, Ankur also talked a lot about that. And I think it's very, very important that you're capturing a lot of user feedback and doing human labeling. But also you can use some cheap online evals for signal. Like I was telling you about these pathological hallucination LLM problems. That's a very classic example of something. Oops, sorry about that. Example of something that it's very easy to score online, and you don't have to make any LLM calls, so you're not going to spend all your budget doing that. Okay, cool. Yeah, I'm running out of time, I think. But here's one last tip that was really useful to us when we were rolling out a new agent architecture behind the scenes. So the spans in the logs from live runs, they also have expected fields. Not only data sets have expected fields, but in your trace, any span in your trace, not only the top level trace, but any span, you can also assign it an expected value. So you can get really creative with how you calculate these. But something that was particularly useful for us is when you're trying to run a new version or you're trying to revamp a part of your architecture and you feel like it's rather risky to just YOLO. It's very useful to run both the old and new versions in parallel, and then you keep feeding the old version to the user, but the new version gets a new span. You wrap that into a span. And then you can kind of make the output of the old version the expected value of the new version, of the span of the new version. And now you can just compare. Braintrust will automatically score those, right? If they're not the same, then that's very good signal for you to go look. So something that I was doing at one point when we were doing a complicated agent architecture change at Zapier Agents was I was just looking at the logs every day, and any score for that span that was below 100%, I would go look and see what was wrong, or sometimes it was low score because the new version did better, which is what I wanted. So we just swap the expected with the output and add it to a data set. And a bonus of that is that once you get rid of the old version, now you have this data set that you can keep, and then you can use it to kind of bootstrap the data set, the evals for your new version that you have online. Cool. Yeah, that was everything I had. I hope that was interesting / useful. I'll hand it over to Jack now, I believe.
Awesome. Thank you, Ankur, and thank you, Vitor. Really, really awesome session there. We'll now move into our live QA session. Folks have been posting in the QA, so we'll run that way. If you guys have any questions that come up, please keep putting them in there. So the first question is for Vitor. It's from Matt. It says, I'd be curious to hear your thoughts around iterating on tool configuration for agents, specifically testing different sets of tools or tool definitions without making any other changes. I'm unsure what the most effective order is in which to optimize things for these systems, but how you structure your tools can have a big impact. Adding too many tools can overload the model and deteriorate performance, etc. I often find myself reworking tools alone with only minor tweaks to prompts.
Yeah, that's a great question, Matt. And I mean, I think that your intuition is right? The more tools that you show to the agent, the higher chance that it's going to do something wrong. And that's actually one of the reasons why with Zapier Agents, we don't try to give it access to a bunch of, well, we have more than 7,000 apps, so it would be just doesn't even fit into the amount of tokens for the agent. But one of the early decisions that we made was exactly that we could kind of constrain that by letting the user pick and start showing suggestions. Like when you're typing in the instructions box, we start proposing suggestions. And then if the user picks one of those suggestions, then that's implicit feedback for us that suggestion was good. So with that, with that system in place, even if we're not using those suggestions for anything, or we don't use them to calculate dynamically which tools we show to the agent, we're now starting to build this data set, right? So there's a little bit about that flywheel. We can start to build this data set, which has even signal from the live runs. And now we can build a pipeline where, the agent doesn't see all the tools that it could have available all at once, but we do a retrieval where we look at what the user is asking, and then we can retrieve only the tools that we find are relevant for that specific question. So that's one of the ways that I kind of tend to look at it. And I also agree with you. I also find myself just tuning the description of a tool or a description of a single parameter of a tool. I also found that I get some accuracy boosts when I add the description of the tool to the system prompt itself instead of just in the tool description. And I don't know. I read about some people preferring just showing the tools as TypeScript definitions in the system prompt instead of passing them as tools. I know that Replit does that for their agents, so I think there's still a lot that we're figuring out how to best deal with this.
Awesome. Thank you. Next one's for Ankur. Can you briefly describe the process of transforming log data to data sets that is ready for running evals? Is that a well-defined automated process in Braintrust?
Yes. So Vitor talked about it a little bit. We sort of think of this flow as logs to data sets to evals. And it's quite well defined in Braintrust. I think there's a lot more that we can do. And I would actually say that being good or helping our customers get data from logs to their evals is probably like our main goal in life, you know. So I think it's kind of like a long-term problem that we work on, but it is really well defined in Braintrust. And I think probably one of the most important things about Braintrust is that you end up using the same code to instrument your production systems as you do your evals. And that's important because it means that you can reuse that instrumentation in both contexts. But it also means that your logs, the shape of the data that you log, is exactly the same as the shape of the data that you run evals on. And so as you move data from your logs into data sets and then use them in evals, you don't need to do any additional ETL.
Great. I think this is for Vitor, but Ankur, I think you can speak to this as well from what we hear from other customers. How are you designing data use terms to make sure companies who are anti-using their data to train models, whether you're actually training a model or just modifying the chain, can contribute to this feedback loop? I think that there's two forms of it. I think because I think for Vitor, it's probably asking his own customers, but then there's the
Yeah.
data aspect for Braintrust as well.
Yeah, I can start with my perspective. So yeah, I mean, I think a lot of companies don't want you to train on their data, obviously, and we take that really seriously. So I think we never fine-tune models on user data. If we ever do any fine-tuning, it's on data that has been cleaned of any PII, obviously. But we also have at Zapier these kind of levels of graduation of products. Since like Zapier Agents, for example, it's still an experimental product. So when users signed up, we very explicitly tell them that we are not going to train on their data, but if they submit feedback explicitly, we will be able to see those and collect those to allow us to improve the product. And then other products as Zapier, the higher up the like the chain of products, once they reach general availability, then we start treating user data like even more seriously, and we cannot even do that. So we have a lot of PII pipelines in place to make sure that we're not saving those or storing them for longer than we can, and complying to all of that.
Awesome, thank you. And then Vitor, I think, or actually Ankur, do you want to speak to any of that from other?
Oh, no, I think Vitor's answer was awesome.
Sweet. Cool. I think this can be a question for Vitor. Is overall, like you chatted about bolstering data sets via capturing logs. How do you think about like creating a data set from scratch for a new feature? Specifically, like how are you designing thinking about the size of it, the content that you're including? How are you incorporating like context or like chat history or any of those applicable things?
Yeah, that's a great question, and I think my perspective on it has changed over the last year. But I think I want to emphasize what Ankur said, that the most important thing is that you're starting to build a flywheel, and then once you're seeing like those live runs, you start kind of noticing the specific discrete spots in your app where you want to kind of isolate them and build like discrete data sets for those. But to kind of answer your actual question, the way that I design those discrete data sets today is I try to first you need to make sure that if your live run has any side effects, that you have a way to capture the inputs and outputs of those side effects, so you can mock them when you're running the eval. One very classic example for us is if the user is like sending a tool call to a third party app, we obviously don't want to like reproduce that that tool call, so we have to mock it. But also when an agent is deciding, if we have a tool to send a message in Slack, the channels available to send a message in Slack depends on the user's Slack account, right? So we can't just go fetch the user's channels. So we also mock that during the log, and we store all of that as metadata in the traces so that we can reproduce that later and then build our data set from there. And I think my biggest tip is to try to kind of reduce the inputs to the minimum amount of data needed to reproduce the run entirely. So the best you can do is if the span that is going to become a row in your data set is one-to-one with the function that you're going to invoke from inside the Braintrust like eval SDK helper, because then you just kind of like load the data set, pipe the input into the function, and then you're pretty much done. And I think even though it takes a little bit of like thinking behind how you're going to organize your code and everything for that, it pays off immensely because now adding a new row to a data set is just so easy. There's zero friction. So we have data sets with, they're getting to like the thousands of rows because it's just so easy to find anything that is interesting and you just boom, click, add to data set and you're done. And then next time the eval runs, it's going to pick it up. Hopefully that's helpful.
Awesome. Thank you. Another one here is where do you put the queue of feedback to review? Is that in Braintrust?
Yeah, you can. We don't do that on feedback run. Sorry, we don't do that on my brain is melting because it's 7 p.m. here. We don't do this in Braintrust, but you can definitely do it in Braintrust. You could have a score which needs like a human review, right? And then you can have a filter for your logs where it just filters by all of the runs that have had some negative feedback, and then you can either filter on some metadata tag that you add that said like reviewed, or you can have another score which is like the label that you want to categorize that feedback in. So you can definitely build that in Braintrust. We built this in React Admin. We have an internal admin platform where we do this. And actually, some of the feedback that we had on how we wish Braintrust had something like that led to some of the Braintrust features that they have now. It's like you can render an iframe for parts of a span to help you exactly with this type of a flow where you want to review and there's like some specific of your span that would be easier to see with the custom UI and things like that. So you can definitely build this in Braintrust. Yeah.
Awesome. I think we have time for a couple more here. Pre-launch, i.e., before you have any users, what kind of evals can one do? I know you chatted about that a little bit, but kind of maybe reiterating the difference between those.
Yeah, sure. I think it's a bit vibes based, I guess. Or if you have some beta testers, ask them to give you some feedback or ask them to try the product and you're seeing what they're doing, full story or behind their shoulders. But for us, that meant just literally a static list of this input with this chat history. This is the output we want. And then we would just go through that list before launch to make sure that everything was working okay. But I want to emphasize that it's important that you already can collect feedback when you launch, right? So make sure you build. It can be very simple. Just send all the logs to Braintrust so you can like review them later, or just push them to your Postgres database or whatever. Just make sure you have something in place to start collecting the feedback because that's where the fun starts. That's where you start building that flywheel. Ankur mentioned this a little bit as well, but don't try to predict everything up front. It's a stochastic system, but you're not going to be able to predict everything, and it's also all about probabilities, right? So you want to make sure you're able to capture like the variety of use cases and inputs instead of trying to predict everything up front.
Awesome. Well, I think we're running up on time here, so apologies if we didn't get to all the questions in the chat. I know there's a couple remaining, but would like to say a huge thank you to Ankur and Vitor for sharing these insights, and of course to all of you all for joining and making it such an interactive session. Ornella posted some info in the chat about follow-ups here, but want to reiterate that we'll be sending the recording out for this webinar, so keep an eye on your inbox. And if you're interested in trying out Braintrust, it's completely free to get started. Just sign up on the website. If you have any remaining questions or ones that come up after the session or just want to chat, through the specifics of your use case, don't hesitate to reach out at info@braintrust.dev. We'd love to hear from you, and are happy to chat all things AI agents or just evals in general. So thanks again, everyone, and enjoy the rest of your week, and see you next time.